Hello everybody, welcome to the Lockdown Mock Mark Scheme. So alongside the personal feedback that you've been provided, I'd like you to do two things. I'd like you to listen to that and annotate your exams, and I'd also like you to listen to this mark scheme as well. If you've missed anywhere, if you've dropped any marks, I'd like you to identify why. If you've got full marks on a question, I'd like you to reflect on how you managed to access those full marks. If you know why, that's fantastic, but I want you to make it clear that you do. If you think it might be fluke, then you can reassure yourself that there were some good reasons behind why that was the case. So the things that we were asked to mark here, so you could be asked to consider a diagram and label it. So we're going to go through them all together and you'll see which one it is. So we've got axon, and the axon is this thing here that runs up to the terminal buttons. Okay, so that's the axon of the presynaptic neuron. So we know it's not axon. The dendrite is the other side. So the information, it receives the information from the receptors. The neurotransmitters are all these little blobs over here. The receptor sites are here, so that's box 2, and then the vesicles are the large blobs with the small neurotransmitters inside them. So box 1 is the vesicles holding the neurotransmitters. Okay, and box 2 is the receptors. I think almost everybody got box 2 receptors, but there are a few people who suggested neurotransmitters. But these big sacs, these vesicle sacs, are the vesicles, and that's what the arrow was pointing at. Okay. You've got to explain the process of synaptic transmission for 4 marks. The first thing you would want to talk about is the action potential running down the axon of the presynaptic terminal. Then you want to talk about the triggering the release of neurotransmitters from the vesicles, the neurotransmitters binding with receptors on the postsynaptic membrane, and then the neurotransmitters are released back into the synapse and reabsorbed in a process called reuptake. So you've got the beginning, which is sort of the first, maybe the second bullet point. You've got the middle, which is the receptors, and you could also talk about the neurotransmitters in the synapse. And then you've got the end, which is they're released back into the synapse and reabsorbed in a process called reuptake. And you need that beginning, middle, and end to achieve the marks. Okay, so if you look at this image again, you've got the synaptic transmission running down the axon. We've just pointed out where the axon is. On the left, these two, the start of the neuron. It then triggers the vesicles to move to the edge of the terminal buttons, or the edge of the neuron, whatever you would like to call it. And then the neurotransmitters are released into the synaptic gap. They go across the synapse and bind to the receptors, and as you can see here, there's 2 neurotransmitters bound to the receptors that the arrows are pointing to. They are then released back into the gap, and then you see these little black 2 stick things here with neurotransmitters. That is the neurotransmitters being reabsorbed through the transporters into the vesicles. Okay, so that is the process. Remember, there's my YouTube video on here explaining this from last year. There's also hundreds of other really good YouTube tutorials that you can use as well. You do want to crack this because it could come up in your exam, your mock exam. A really important thing to state is the neurotransmitters, the ones you can see bound to the receptors, they do not go any further into the synapse, into the neurons. The closest they get to the next neuron is the receptor, and that is it. The neurotransmitters are in the vesicles, they're in the synapse, or they're in the receptors, and that is it. Okay? A word of warning to you all. Not all, some. I saw the same terminology come up over and over again. There are some websites that are no good. For example, Tutor2You. Over the years, I've had lots of people copy and paste Tutor2You information into the answers, into the exams, and I've yet to see them achieve very good marks. Very occasionally, maybe. Tutor2You has good content, very good content. They are not very good in their answers at providing you with structure, exam structure. Okay, So please be careful. I caution against using copying and pasting text from any particular website, because one, it's probably not going to meet the criteria. If it does, that's great, but you haven't learned anything from it. Okay, so just bear that in mind. Occasionally on exam papers I've mentioned it to people, at other times I haven't, because as I said, I told you from the beginning that this wasn't based on the this wouldn't inform your mark at the end of the year, but it was really good practice. If you choose not to engage and use that practice wisely, that is entirely up to you as adults. Okay, and then we've got this diagram, which you're all probably hopefully sick to the back teeth of seeing. So we've got A, which is Broca's area, B, which is the motor cortex, C, which is the somatosensory cortex, and the way I remember these is M and S. So if you see the front of the brain, that's where you'd imagine the eyes are. You've got M, which is the motor cortex, and then S behind it, or I remember S for somatosensory, S for shy because it hides behind it. Then you've got the visual cortex, and I imagine the light, a beam of light shooting into the visual cortex and hitting the back of the brain. So that's how I remember the visual cortex. And then you've got E, which is Wernicke's area, which is parallel to A, which is Broca's area, so the language centres. And then you've got F, which is the auditory cortex, which is just a little lower down. And I like to imagine that's a bit like, if you kind of look at it, you can almost imagine it's a bit like an earlobe, like an ear, because you can hear. Okay. Then we've got briefly explain how unusual behaviour in split brain patients could be tested in an experiment for 2 marks. Explain how. If you see explain how, we've talked about this before, it is a step-by-step guide. Okay, and it is Sperry's research. You don't have to talk about Sperry's research, but it's the only type of split brain research that you are aware of, so it would be very wise to talk about that research. You do not talk about the findings, you do not talk about the conclusion, and it is only 2 marks, but you do need some detail in there. So what I suggested was participants could be asked to stare at a dot on the screen to prevent them from moving their eyes. Then an image would be flashed in either the right or the left visual field. They would then be asked to state the name of the object in the image. You can talk about slightly different things, but what's really important is that they are looking at the dot. The image is being flashed in the right or the left visual field, not the hemispheres. You can't flash anything in people's hemispheres unless you're breaking every ethical guideline. And then I said they were asked to state the name. They could be asked to draw it. So there are a couple of variations on this. So if you're slightly different and you've got the 2 marks, don't worry. But if you haven't got the 2 marks, that's the detail they were looking for. And it was explain how. So a step-by-step guide to how they studied the behaviour. Briefly evaluate research using split brain patients. This time they wanted research from split brain patients, okay? Most of you that have accessed the full marks, you've talked about standardised procedure or sample size or control group, no epilepsy, confounding variables. You've got several to choose from there. Some of you, and they're the ones I'd recommend. They're the easiest ones for this example. Some of you talked about Turk, and I think maybe somebody talked about Rogers as well. I can't. If you did, and I didn't give you any marks, get in touch with me, and I will have another look at your paper to cover those. Okay. So if there's anything you're not sure of, please do get in touch with me about this one in particular. However, for most of you, or almost all of you, I didn't see the P structure. And because of that, so I never looked at an answer and didn't give people marks because they hadn't used the P structure. However, people, because they didn't use the P structure, didn't show off their knowledge to the best of their abilities. And therefore, they didn't access the full marks. So if it says evaluate, you need to use the P structure to show off your abilities, your evaluation skill. Go really drill down into detail. You could get 4 marks from just 1 P structure evaluation point. Okay. Then we had which is the feature of functional magnetic fMRI, resonance imaging, directly measuring electrical activity of neurons using electrodes implanted inside the brain. That is not the correct answer because that is deep brain stimulation. You do not need to be aware of deep brain stimulation, but that's what they're describing. By knowing that it doesn't describe fMRI, you're enough not to tick that one. Directly measuring electrical activity using electrodes. Directly. Well, we know that fMRIs are indirect, so it can't be that one. This one is EEGs or ERPs, electrodes on the scalp, electrical activity, EEGs, ERPs. Indirectly measuring the electrical activity of neurons by recording changes in blood flow. This is fMRIs because it's indirect and it is blood flow. Okay, and indirectly measuring the electrical activity of neurons by recording changes in neurotransmitter release. So again, it's not about neurotransmitters, it's about blood flow. Okay, so the word blood should have been the one that cued you into fMRIs. So with this one, it's outlined one difference between EEGs and ERPs. And again, I saw this wording come up quite a few times. So you're allowed to use your notes. You're more than welcome to. If you are relying very heavily on any source, then you are not preparing yourself well for mock exams. So you can use it, but just make sure that you are able to explain it in your own words as well. What's really important about this one, and any question in an exam that says outline one difference, is you must make it clear it's a difference. I don't necessarily agree with this, but on the mark scheme, if you have one sentence EEGs record general brain activity linked to the states in the brain, full stop. ERPs use specific stimulus to elicit responses from participants, full stop, then you would not get the marks. If you said exactly the same thing, but you used the word whereas, then you would get the marks. Okay, I don't agree with it, but it's something that's really important for you to be aware of in the mark scheme. Okay, so if you didn't do this, it's completely understandable. I think it's important that you do it now because if you need to do it in the mock exam, you'll remember. If you just copied and pasted the answer from somewhere, please make sure you understand why that answer is an answer that got you 2 marks. Briefly evaluate the use of EEGs. You don't even need to worry about the rest of it. Cortical specialisation, fancy word for localisation, so you're already aware of it. So specialised parts in the brain. It is the evaluation part that you need. If you do not start a strength or weakness is, or something along those lines, then you are not letting yourself fully access the marks, okay? On the mark scheme, they suggest lots and lots of different things. However, the ones that you have been trained to use effectively, and you can definitely use the ones on the mark scheme. I never not gave people points because I went, oh, that's not on the mark, that's not what I taught them. But the danger is if you use something off the mark scheme and you haven't effectively explained it, then it is going to be harder to access the marks. Okay, so again, evaluation, so it's the P structure, point, example, explain, link. A strength is, for example, this is an example because, this is a strength because, okay? And then the kind of things that you could talk about. Now, I've included all of them, but the one we're focusing on is EEGs. Your spatial resolution is poor. So the smallest measurement that the scan can detect has a precision of about 1 centimetre. That is not very good. When you think how big the brain is, a centimetre is a huge area of brain. You want to link it back to validity. This means that you can't be confident in cause and effect. You cannot be confident that a specific part of the brain is what is causing this thought process or is involved in this functioning. So you cannot be confident of validity. Evaluation, you always link it back to validity. And then temporal resolution. And this is about the precision of the measurement with respect to time. So in EEGs, it is milliseconds. So the temporal resolution or temporal validity is really, really high. So you can be very confident because there is no lag or no delay. And I saw a few people use that term, which is really good. You can be confident that the stimulus you was presented and the brain activity you see is the stimulus is the cause of that brain activity. So you can be confident in the validity of your measure. So link it back to validity. Okay.